So in general, it's pretty hard to compare slopes of two different lines unless they're on the same graph. But if you have two lines on the same graph using the same axes, then comparing them is actually very helpful. What do the slopes of these two lines tell us? So we're told from the graph that we're comparing road trips, and it looks like comparing road trips between Pennington and Williams. And a really important thing to start with is let's think about the units of the slopes. So slope units. That's going to be the units of the rise over the units of the run, which is going to be miles per hour. So what are the slopes telling us? They're telling us the speed of the two different road trips. And so here's Pennington's, and we can see that it's steeper than Williams's slope. So what we can tell by comparing these two slopes is that Pennington's road trip, or I guess I'll say Pennington's driving faster on his road trip, faster than Williams on his road trip. So let's do one more example here. The miles driven and gasoline consumed is graphed for two different vehicles, and we want to use the slopes to compare the gas mileage. So let's start by thinking again about the units of slope. The units of slope are going to be the rise, which is miles, per run, which is gallons. So it's telling us how many miles we can drive per gallon of gasoline. These are very American units. In Canada, we'd be using kilometers per liter, but we can still compare just as well using miles per gallon. So let's start with the slope of the red line. I'll call it slope 1. And we need the rise and the run. I'm going to pick this convenient point, and it starts at 0, 0, 0, so I'll pick that convenient point. And I can see that the rise is 150 miles. Per run is 6 gallons, going from 0 over to 6. So 150 divided by 6. That's equal to 26.7 miles per gallon. So what that means is that for every gallon of gasoline, this vehicle can drive 26.7 miles. Now let's do the same analysis for slope 2. So this time, where's a convenient point on the line? I think it's about here. So you notice I'm using a different rise and run because it's a different line, but I'm just picking the point out of convenience. So I can see very clearly that I rise from 0 up to 50. So that's my rise is 50. And my run is from 0 gallons to 5 gallons. So that's a run of 5. So again, I'm just trying to pick points on the line that are very convenient for finding the rise and run. So 50 divided by 5 is 10 miles per gallon. So now what we're going to do is use these slopes to compare the gas mileage. And so we can see that this vehicle from the red line is way more fuel efficient than the vehicle from the blue line. In fact, we calculate the difference in gas mileage is equal to 26.7 minus 10, or 16.7 miles per liter. So in other words, the car that was graphed in red, that car can drive 16.7 miles. Oh, it shouldn't be per liter, it should be per gallon, sorry. 16.7 miles further per gallon of gasoline. And so you see that the car from the red line is way more fuel efficient than the car from the blue line. And so we could write that out. Vehicle from red line way more fuel efficient. So now we've compared the two slopes, and we did that by calculating the difference between their values, 16.7 miles per gallon, and we've interpreted that difference, that one vehicle is way more fuel efficient than the other.